Right, it looks like it's been initialized. Simultaneous equations can be generated from storylines. It's complicated because you've got to read the story carefully, get an equation out of it, then get another equation out of it, and then solve whatever's required in the problem. So on page 150, I'm faced with question 8. It says Dan sells decorative storage boxes in 2 sizes. The cost of 4 small boxes, and let me just write it out in case I miss it. So 4 small and 3 large come to £63. Alright, so that's the story. The cost of 5 small, so 5 small and 2 large comes to £56. Find the cost of 1 small box. Right. 4 small, right, here goes the cost. 4 smalls, let's call it 4 S's plus 3 L's comes to 63, and 5 S's and 2 L's comes to 56. Now look, there's nothing the same there, so I think I'll upgrade the L's into 6's. So if I multiply this one by 2, multiply this one by 3, it should be good. Let's go and do that one. Multiplying throughout by 2. 8 small boxes plus 6 large boxes comes to £126. Bottom one, 15 small boxes plus 6 large boxes comes to £168. Now I've got to subtract, obviously, to get rid of the 6 large boxes. So subtracting 6 large minus 6 large means I've got no large for now. It doesn't matter that we go into negative territory. I can say 15 times 8 and 168 take 126. That means writing it again on top of each other. So let's go for negative, doesn't matter. Right, 15, 8 take away 15 is going to be minus 7 smalls. That's gone bye-byes. The difference between 168 and 126 is going to be roughly 42, so that's going to be minus £42. So the small box is going to be minus £42 divided by minus 7. So the small box is going to cost me exactly £6 because you know, 42 divided by 76 and minus divided by minus is plus anyway. So I found the cost of the small box. Well done me. So I'm happy with that. I could have substituted it back in there to find the price of the large box. It doesn't ask me to do it. I can't be bothered really. Question 9. Jack is X years old. So Jack is X. Jill is Y years old. I can feel a nursery rhyme coming on. So Jack is Y years old. The sum of their ages is 60. So Jack and Jill are 60 together. Right. Jack is 6 years older than Jill. Well, if Jack is 6 years older than Jill, then I reckon Jack equals Jill plus 6. What do you think of that then, eh? What do you think of that? So there we go. Now, write down a pair of simultaneous equations, blah de blah de blah. Solve them to find the value of X and Y. In other words, the ages of Jack and Jill. Well, I've not taught you this method yet in terms of substituting one equation into another. So what I'm going to do is bring the Y over here and subtract. So altogether, I've got X plus Y equals 60. I've got X minus Y equals 6. Simple equation, add it. Because the Y's and the minus Y's will disappear when you try and add them. So let's just do it. I've got 2 X's equals 66. Therefore Jack is 33 years old. Now what about Jilly? Well, Jill is Y. So here I go. So put it inside here. I've got 33. Put it down there. 33 plus Y, which is Jill, all comes to 60. So Jill is going to be 60 minus Jack's 33. 60 take away 33 is 20 something, 27. As you can see, there's 6 years between them. Jill's 27, Jack's 33, and I've answered that question for you. Alright, that's Jack and Jill going up the hill comparing their ages. Now, we've got this chap called Hasif. Okay then. He has 17 coins in his pocket. Fine. Some are 5p's and some are 10p's. Let's just write the story. 17 coins. I've got 5p's. I've got 10p's. and it says their total value is £1.40. Alright, let's just set up the story. How many 5p coins does he have? Okay, their total value. Alright, so I've got 5p, I've got X 5p's, and I've got Y lots of 10p's. Is that alright? I should go X5 and Y10, but that's backwards in algebra. So how many 5p's I multiply by 5, how many 10p's I multiply by 10, and the total will come to 140 pence. That's a simultaneous equation. Now I've got 17 coins in total, so in other words the number of 5's plus the number of 10p coins should come to 17. Is that fair enough? That's what it says there. Number of 5p's, the number of 10p's comes to 17. 5 lots of the number of 5p's and 10 lots of the number of 10p's comes to 140. I've got two simultaneous equations and I have to treat them simultaneously. If we multiply by 5, we can go for 5x's throughout. So you stay put, you get multiplied by 5. So let's upgrade. 5x plus 10y is 140. Multiplying by 5, I've got 5x plus 5y is 50 plus 35 will be 85. I can then subtract to get rid of the x's. So 5x take away 5x, no x. 10 take away 5, I've got 5y's left. 140 and 85, 15 is 55. So y is 55 over 5, which equals 11. Therefore I have 11 10p coins. 11 times 10p coins. Is that alright? That's what I've got, because y is the number of 10p's. Okay, so I've got 11 for y. So substitute the 11 in the y. I go x plus 11 is 17. Therefore, without getting all fancy with it, 17 take away 11, I've got 6 lots of 5p coins. So I've got 6 times 5p coins. And that's all there is to it, really. How many 5p coins? I just wanted 5p coins. Anyway, I've got 6 5p coins. I just happen to work it out the y first. Doesn't matter. A tough act. Question 11 looks really challenging. It says Paul is thinking of a fraction. So this is what's in Paul's brain. He's thinking something. I don't know why he's doing this. Maybe he's being grounded. If he adds 4 to the numerator, in other words, whatever his x value, if he adds 4 to that, and to the denominator, in other words, y plus 4, his fraction comes to 3/5. Oh, I can't wait. If he subtracts 6 from the numerator, in other words, x minus 6, and from the denominator, that's y minus 6, his fraction is a third. What is Paul's fraction? I've now suddenly gotten to incorporate all this into my brain and get an answer. Right, well, let's tidy up this mess, shall we? Nobody likes letters, top and bottom, and fractions. So if I cross multiply in both cases, so you're going to go over there and you are going to go over there, and we're going to get 5 with x plus 4 will become 3 with y plus 4. Let's tidy this up a little bit. I've got 5x plus 20 equals 3y plus 12. Bring the x's and y's together. 5x minus 3y equals 12 minus 20. Simplifying further, 5x minus 3y equals minus 8. Now stop there, because I've got myself a nice little equation. Not simultaneous yet. Let's do his brother, same way. You go over there and you come over here, and we'll do the same to him, shall we? Right, 3 multiplied by x minus 6 equals 1 times y minus 6, which is y minus 6. Multiply out. 3x minus 18 equals y minus 6. You bring the y's to me, so 3x minus y equals minus 6. Please note the minus belongs to the 6, plus the 18. Tiny it up a little bit. 3x minus y equals 12, and that is another very handsome little equation. Now we can treat them simultaneously. So you two guys come with me, we'll work in red. I've got 5x minus 3y is minus 8, and I've got 3y, oops, my eye skipped over to the y, and I've got 3x minus a single y is 12. Well, no point upgrading these to 15s, let's just upgrade these to 3y's. So that's going to become, leave that one on its own, 5x minus 3y is minus 8, multiplied by 3 at the bottom there. 9x minus 3y will become 36. So I just did times 1 and times 3 there, just for the record. Now we can do our sum. I've got minus listen to this, I've got minus 3y, and I want to get rid of the other minus 3y. The only way to do it, believe it or not, is to subtract. Work with me on this one and listen carefully. I've got 5x minus 9x, that's minus 4x, no problem. Minus 3y minus 3y means minus 3y plus 3y, because a double minus clash in the middle. Therefore my y's have gone for the moment. Now minus 8 minus 36 is minus 42. Let's just check I've got it right. 8 and 36 is, no, 44. I tell lies, though not deliberately. So 36 and 8 is 44, so that's that. Now that makes x to be minus 44 over 4, well, minus 4 actually. That comes to positive 11, so x is 11. Easy peasy. Now let's substitute this into the easiest equation I can find. I think if I put the x value for 11 in there, that should be fine. So here I go. 3 lots of 11 minus y is 12, so 33 minus y is 12, so minus y is going to be 12, take away the 33, so minus y is going to be 33 take away 12 is 20 something, isn't it? 21, but it's negative 21, and therefore y is 21. So what is this chappie thinking about? Paul is thinking about x divided by y, and that is actually, where's my x gone? 11 over 21. Again, we haven't got a clue why he was thinking these things, but he was, and he made our lives very, very difficult, especially mine. Now study this one, it's so worth your while, and I'm going to stop there, and that's equations being formed from storylines and then solved.